Hello everyone. In our last video tutorials, we have discussed what is functional programming, what are higher order functions, and a couple of higher order functions also we discussed, like map, flat map, and compact map and all. And in this tutorial, let's discuss the rest of the higher order functions like filter, reduce, and sorted, and the other stuff. So first, let's start with filter. Filter is also a higher order function where it is used to filter the elements in a collection based on the condition we provide, based on the closure we provide. So the only just wanted to highlight the only difference between filter and map is map transforms the collection, and the elements of the returned collection could be of any type. Why? Because it performs a transformation. So if you pass the integers, you can convert those to strings, or if you pass doubles, you can convert those to integers. So it gives a different set of data type. That is the reason the return type of a map is generic type, whereas filter, it just filters the set of elements, the elements in a collection. So the data type of the return type which filter has is also a collection of the same elements. So that's basically the difference between map and filter, where let's see with an example. Let's say let me take an array of 3 5 66 8. So in this I just want to take a collection which are divisible by, so the condition we need to provide, and if the value is true, then that element gets added to the new array which we build. So let's say this is even r, and we don't need it for now, so we'll go with the shorthand syntax which we already discussed, which is $0 divided by 2 is equal to 0. Then that should go to even array. So if we print this and let me execute it, so we got the even number collection in the array. Not only that, let's say if we have models also. Let's say I'm taking a model called product, in which it's having an ID, it's having a name, and it's having a price, and it's having an offer available. Let's say it's a bool, whether offer is available on this product or not. So, and let's say I have added some products to my shopping cart. Let me create a product array, for example 1 something. I'll give price 12.0, offer available, no, okay, name, let's say this is 111. So like this, let me create a couple of products in which I'll explain product 2, product 3, product 4. So let it be 2, let it be 3, let it be 4, and product name is based on the ID I'm giving, for just for an example, price, let it be offer available true. So only second and third product are having offers, let's say. So in this I just want to filter out what are all the products which are having offer available as true. So what I can do is let offers is equal to, from products I would filter this, we can use it, or it's not also, it's when p dot offer available. If this is true, then that comes to offer. So if I see what is there in the offers, so what it does is, okay, 2 and 4 is having the offers. Not only at this level, for example, let me say offer available and offer, so what is the percentage of discount also, if we want to see, and let me say it's double, or let's keep it very So discount also, so discount, let's say, let me say like as it's no discount, no discount, no, it's having discount of 10%, it's having a discount of 0. Why? Because or we can keep it optional also, or discount of, let's say, 20%. So now I want to filter like what and all the products that are having the offer, and also which is greater than 10% at least, or which is greater than 20% at least. So third one also, let me make it true, but this time this is 15. So now let me say I want to filter the products which are having the offer available and the discount percentages, and I'm sorry, and disc p dot discount, sorry, and p dot discount greater than 15. The product should be having the offer and the discount offer should be greater than, or let's say, let's 10. Then it should give me only 3 and 4. So let's see whether it's working or not. Now yes, 3, sorry, okay, offers 3, and let me open the console. For now I can print it to offer. Offers, sorry, let me run it again. Okay, third one is having, and fourth one is having offer and a discount of greater than 10%. Like that, it's very simple to filter out the items from a collection. So usually from the service responses we get a list of items, and from which, based on the user search, if we need to filter something based on first time, last time, or anything. So this higher order function is very helpful. And the result collection elements data type is same as the input collection, the source collection data type. For example, if it is a collection of products, of course the result, if it is a collection of products, the result is also going to be collection of products. It's not like map. Why? Because we're not doing any transformation, we're just filtering. So this can have 0 items and more than 0 items. So when we are accessing offers dot first or offers dot, when we're looping it, we need to make sure that whether it is the result type is having items available or not. For example, if I do like this, the this will be having empty. Why? Because no one in this product list is having a discount of greater than 20%. So we need to check whether this filter is having items or not, and then we need to play with the UI. So we discussed filter, let's discuss sorted higher order function. Like filter, sorted also sorts the collection based on the logic we provide, and it provides a collection. It doesn't filter, it doesn't map, but it provides the collection in the sorting order. So technically speaking, the input collection count is equal to the output collection count if we are using the sorted. Why? Because we're not doing anything, we're just sorting the items. So the output is also not going to be generic type like map, it's going to be the same collection. And when we use it, let me take some names array, let's say Bob, Tony, and Alex. Okay, and so let me sort this sorted name. So what I can simply do is, if I just need ascending order, I can just simply use this sorted without any closure, nothing on all. But so see, it sorted in the alphabetical order. No, if I need it the other way, then what I need to do is I need to pass, that means I want T should be first. So in the descending order, then what I need to do is I need to pass the expression, where by. So here I need to as it is an array of collection, it is showing so if you have observed, Swift auto completes it, and what you can see, the strings. If it is an array of integers, it shows this. So Swift auto completes it, and As this is just ascending and descending related, we don't need to do all that. We have a shorthand method of doing it. If you just need in the reverse order, we can pass greater than operator, so it does the same thing for you. You don't need to see, it does the same thing for you. And if you again need it back, it's just the less than symbol. Okay. And not only for these simple collections, for example, we have a products collection also. In this, I just want to, let's say, sort these items based on the price. So let's say this is some $15, so I want to sort it in an ascending or descending order based on the price. That also we can do. Now let's just say sorted product, let me apply it on. So add products dot sorted. Now what I give is, now I can do like this: p1 p2, I'll take product and parameters. Now I can do like p1 dot price greater than p2 dot price. This is one way of doing it. If I run it, this sorts the array, or let me print it so that we can see in the console, which is here, just the sorted products. So I'm running it now. If we can see 22, 15, 13 and 12. So it's in the descending order. It sorted products based on the price, but in the descending order. But no, if I want to have it in a reverse order, no, less than. Now if I run it, now it's sorted but based on ascending order. 12, price 12, price 13, price 15 and price 22. So like this we can do. And we don't need to take the parameters also. Why? Because if there is only one parameter, where as we are omitting and going with shorthand syntax 0 1, for the second parameter obviously it is $1. So instead of taking this, we can also do like the first parameter. When we're doing the comparison, the first parameter is $0 and the second parameter is obviously $1. So this of course gives the same result. See, this is the shorthand version. If you're not willing to take the parameters and just want to go with the shorthand syntaxes, this we can do. So here we can clearly see like, okay, there is a sort happening based on the price. So that's the beauty of the function programming. And after sorting it, as I already explained it multiple times, now I can filter. Now I can apply filter also. Now I can say like after getting sorted $0 dot or for available. If it is available, then only the sorted products will. So if I run it again, now the collection will have only of sorted but offer available, and let's say $0 dot discount greater than 15. Now it will have only one product. Why? Because sorry, it is not dollar. Now it will have only one product obviously available. Why? Because it is only having offer available with the discount greater than 15. So like this. Now I can map if I want it. So that's, we have discussed this multiple times. That's the beauty of functional programming. Swift every time auto completes it when you are using the higher order function. Why? Because it applies on the collections, and based on the data type in the collection, it does see that it is an array of products, so it does it for you. So that's basically the beauty of functional programming and how we, on why we usually go with that. Now let's discuss another higher order function, which is reduce. It's just returns the result of combining the elements of the sequence using the given closure, where it looks like this, where we can add the initial value and the elements in the collection we can keep on adding, which returns the result. So let's make it very simple. Usually what we do, let's say we have an array of prices of items. Let's say $200, $40, $40, $60 and $100 and $50. So to calculate the sum of the array, usually what we do, so we take a variable called total value. We started with 0 or whatever the value we want to start. So this initial value is nothing but this initial result. So this is where we started, and usually we write the loops, loop through the array, and total value we combine with the we add it like this with each element in the array. So this gives the sum, which is fine. We're able to get our result, which is 450 total sum. Whereas this we already discussed, and that is the reason we go for functional programming. This is imperative programming, where each and every step we need to write, and there is some mutation. Mutation is not good. This total value is getting mutated over here. That is the reason we go for higher order functions. Though when this is the case, not only a simple integer array or double array, if we have a list of products like this, for example, we have an array of products. So, and we want to calculate the price of all the products added. For example, let's say this is a shopping cart. Usually in the shopping cart we add the products, and at the bottom we need to display what is the total value of the added items to the cart, the total price. So for example, these scenarios, we can use the reduce function. It's a higher order function, and so here let sum is equal to, for this numerical array, let me add prices. You reduce, initial value is nothing but the total value. I want to start with 0. Next partial result is nothing but this one, the total value, or some x, let's say, and y is the next element in the array usually. So usually it's the next element, initial result, next partial result, and element. This is the result, which is nothing but the current total value, we can call it as, to better understand. And this is the next element usually. So technically what we do, we add, and so this sum is obviously it's equal to the total value. What we have done using this is the same. So here total value, instead of 0 I can give 10, and here also instead of 0 I can start with some 10. So that's how usually it works. And if I print sum, let's see whether this and this is giving same. Yes, they both are same. So this is as simple as that. And for this products array which we have, let's say these are all the products added to the shopping cart. For example, I want to calculate the sum of all the prices of the products in the shopping cart. Here let's say it is 15, 12, which is 27, plus 13, 40, 40 plus 22, 62, let's say. Now the array here is add products. So let some product, or let's say final bill, is equal to add products, same, reduce 0. Here, as now we understood the concept, it's just I can give it as x plus y. So it's x plus y. I would give on final bill. Let's see how it is. It's 115. Is it 115? Let's see. Did I give price? Sorry, I took array. It is add product. Sorry, this is product, and it's product dot price. Sorry about that. Yes, 62, which we calculated. So the final list of the collection of the sum of all the prices is 62. Okay, so like that we can do. And like that, for example, we want to calculate the total discount that applies to this price. That means the sum of all the discounts of the products in the shopping cart. So it's like 20 plus 30 plus 15, 45. Now the same way I can do, like total discount is equal to products dot reduce initial discount 0, and this is x and this is product just for this, and the total value plus product dot discount. And this, let's print this and see whether reduce is working fine or not. So total discount, if I calculate it, it's 45, correct, which we already calculated. So that's how Swift already given us a very useful higher order functions like map, flat map, compact map, which we already discussed in our earlier tutorials, and reduce, filter, sort, which makes our programming life very easy. We don't need to write the loops, and we don't need to tell each and everything. We don't need to write the imperative programming. We can go for the declarative programming, where and we can chain the stuff also. Like I can apply map first, I can filter that, I can sort that, after that I can do the reduce. Like a chain, we can do so much stuff using this higher order functions.